Hello everyone. In this video we will try to study JK flip-flop with the help of Nand gate and also with the help of IC for the JK flip-flop. So for making a JK flip-flop using Nand gate, we required two 3 input Nand gate, two input Nand gate, two bulb for showing the output, pulse generator, two switches and a DC voltage source of 3 volt, and also we required a 4 channel as oscilloscope in order to see the timing diagram. So before starting the connection we will look up about the theory of JK flip-flop. So JK flip-flop improved version of RS flip-flop in which there is a two input terminal J and K and also a clock pulse for the input and two output state, that is Q state and Q dash state. So this is the symbol for a negative edge triggered JK flip-flop, and we may also have a positive edge triggered flip-flop. In JK flip-flop what we do is basically we take the RS flip-flop and in basically a clocked RS flip-flop, and in which we use a 3 input NAND gate, and a feedback is given from the first NAND gate to the output of the second NAND gate, means the output of the this B NAND gate, and input of the first A1 NAND gate is also connected to the output of the A NAND gate. So basically we are providing a feedback from output to the input in the JK flip-flop. So now we will see the truth table for the JK flip-flop. So for the negative edge triggering flip-flop, so flip-flop works only when clock pulse goes from high to low. So when clock pulse goes high signal to low signal, then if the J value is 0, K value is 0, then there will be no change in the output state of the flip-flop. And when the clock pulse is going from high to low, and at that stage if the J is at a higher logic and K is at a lower logic, then we will get the output state of the Q as a 1 and that of Q dash will be 0, and this is the set state for a flip-flop. Now for the high to going low pulse, if we will apply J signal at a lower logic and K signal at a higher logic, then in this case we will get output state Q as a 0 and Q dash as a 1, that is the reset state of a flip-flop. Now in the next case, when the pulse is going from higher logic to lower logic, then if both the J and K are at a higher logic, then at this time we won't get an undefined case, but we will get a complement case, and this case will keep on varying for each pulse going from high to low. So now we will just connect our circuit and verify this truth table, or basically we visualize in a timing diagram. So we will start the connection. So first of all we will take a RS flip-flop. So basically this is the basic configuration of a RS flip-flop using NAND gate. Now we will make a JK flip-flop. So for that we take a 3 input NAND gate, and first of all we will take a 3 volt DC power source whose positive terminal is connected to key A as well as key B, and also we will take a pulse generator. Now the output of the key A is connected to the input of the first 3 input NAND gate, and output of key B is connected to the one of the input terminal of 3 terminal NAND gate 2. Now the output of this first 3 terminal NAND gate is connected to the input of this 2 terminal NAND gate, and this output is also connected to the second NAND gate of the 2 terminal. Now one of the input terminal of 3 NAND gate are connected together with the clock pulse, and this another input terminal is connected to the feedback. Now we will connect the input terminal of 3 input NAND gate, that is the first NAND gate, to the output of the second 2 input NAND gate, and the input of the second 3 terminal input NAND gate is connected to the output of the first 2 input NAND gate output. So this is the circuit diagram of our JK flip-flop. So now we will connect the oscilloscope for the timing diagram of the wave. So in which the first A channel is connected to the J terminal representing the signal through the J. Channel B is connected to the K terminal for showing the signal of K, and channel C is connected to the clock pulse. and D channel is connected to the Q state of the flip-flop. So now we will verify our truth table using these two LED bulbs, and then we will see the timing diagram in the oscilloscope. So initially, as we switch on the circuit, as we start the pulse, then we can't determine the output of the flip-flop. As soon as we will close the switch S3, that is we apply the signal through the J terminal, then the output state Q become high and Q dash become low, that is the flip-flop become in set state. So as soon as we will open this switch, it remain in the same state. Now if we will close the switch B, that is apply input through the terminal K, then the output state Q becomes 0 and that of Q dash become 1, that is the flip-flop will become in reset state. And if we switch on the circuit, it will remain in the same state. And now in the JK flip-flop, if we will close both the switch, then also it will remain in the same state, but after some time it keep on changing the state. So now we will see these things on our oscilloscope. So as soon as we will start the connection, we will see timing diagram. So as soon as we will switch on the circuit, we will see that the waves are forming, that the clock pulse are rising, and initially we don't determine the state of the flip-flop. So as soon as we will close the switch A, we will see that the flip-flop goes to set position, that is the yellow signal goes to high with that. Now as soon as we will close the next switch, that is the key B, then the flip-flop will goes to reset position on next above going pulse. So here we can see at ongoing pulse from low logic to high logic, flip-flop changes to set to reset state. Now as we open this switch, the signal remain unchanged with the passes of the time. Now again if we will close the key A, then on next raising pulse it will goes to set position. Now in this case, if we will close both the switches, then in this case on next going pulse it goes to reset, and then again in the next going pulse it will goes to set. So this process continues, and this is the timing diagram for our JK flip-flop. So now we will connect these. Now we will make the JK flip-flop with the help of IC. So this is the IC for our JK flip-flop, in which the first terminal is for J, third terminal is for K, and the middle terminal is for the clock pulse. Here it is set and the reset position, and this is the output Q and Q bar. So basically we will connect the input terminal coming from the A to the J, and the input terminal coming to the from B to the K. Clock pulse are connected with the clock pin, and the output Q is connected to the C, and that of Q dash is connected to D. Now we will connect the input of the first switch with the channel A, and the clock signals are connected with the channel B. Now we will switch on the circuit and see the timing diagram. So as soon as we will start the circuit, the waves are, we can see the clock pulse is set at 1. So there is no change in the output as with the change of the clock signal, as we have not provided any of the input terminal. Now if we will switch on this key 1, that is apply the signals from the J, then with the raising pulse it goes set the flip-flop to set position. So as soon as we will apply the clock pulse 1, it set the flip-flop, that is the Q output goes to high and Q bar goes to low, and flip-flop will be in set state. Now as soon as we will close switch B and change the signal, that is the when signal goes from the low to high, then only it goes to the next state. So as signal goes from low to high, we can see that the flip-flop has reset, goes to reset position, and again if we will close both the switches, then the output won't change until and unless the clock pulse are changed. As soon as we will change the clock pulse, the output will changes on the going pulse from low to high, that is it will goes to set position, and for the next going pulse from low to high it will set the output to the reset position. So here we can see, And in this way we have get all the cases that for negative pulse, changing the pulse from 0 to high, if we switch apply signal from the J, it will set the flip flop to the set position. And for the pulse going from low to high, if we will apply signal from the K, then it will set the flip flop to the reset state. And now if both the switches are closed, then on raising pulse it changes from reset to set state and then set to reset state. Hence for all the different cases we will get output, and there is no any cases of undefined. There is, we can't get any undefined case. So this is our simple timing diagram for the JK flip flop. So that's all about the JK flip flop. We have made the circuit diagram as well as verified the truth table using bulb, and also we have seen the timing diagram. So, thank you.